Okay, here is a second example of a t-test for two samples from beginning to end. Hopefully you'll find this illuminating, because this is exactly what you are going to have to do and be doing on your problem set for this week. First thing, and again, this is available on Blackboard, but the first thing I want to introduce to you are the hypotheses, because there's important information that we can learn from the hypotheses. There they are on the screen, but you can also download this document from Blackboard, and I will also read them. H sub 1, the research hypothesis. Social science majors will skip class a significantly different number of times than fine arts major. Okay, now, we know right away that we're going to need a two-tailed test, because we're not saying that social science majors will skip class more than fine arts. We're not saying that social science majors will skip less than fine arts. We're simply saying they will skip a different number of times than fine arts majors. The null hypothesis, H sub 0, is social science majors will skip class an equal or same number of times, and I purposely have been using those two terms, equal, same, because that's saying the same thing as fine arts majors. So H sub 1, saying social science is different than fine arts majors regarding the amount that they skip class. H sub 0, null, is saying social science majors are the same as fine arts majors regarding the extent to which they skip class. Next, we know we need a two-tailed test from the hypotheses. We are being asked to test that hypothesis. These hypotheses are specifically test the null hypothesis. As a quick reminder, that's the hypothesis that we refer to. That's the hypothesis that we are putting to the test. We're going to test that null hypothesis at the 0.01 level. So that's the size of our alpha region. Okay, so pretty much the same setup as before, except now we need a two-tailed test at the 0.05 level. Now, here's our information. Here's the data. Social science majors, we've got N sub 1, that's our sample, so we have 15 social science majors. N equals 15, N sub 1 equals 15. Mean sub 1 equals 3 times per semester, that's an average, so social science majors skip class on average 3 times per semester. And we have a standard deviation sub 1 of 0.8 times a semester. So social science majors, sample size of 15, a mean of 3 times a semester, and a standard deviation of 0.8 times a semester. Fine arts, same sample size, N sub 2 equals 15. So we have 15 fine arts majors. We have a mean sub 2 of 8 times, wow, 3 versus 8. That seems like a big difference, but we don't know if it's big enough to warrant rejecting the null hypothesis. But we do know that fine arts majors, according to this sample, do skip class more. We just don't know if the amount they skip is so great that we can warrant saying there's something other than sampling error or chance going on there. So a mean of 8 times a semester and a standard deviation, S with a hat sub 2, or standard deviation sub 2, of 3 times a semester. So this is the given information. Below on that first page, I have set up the drawing that you will see again. This is the t probability distribution. We know from the hypothesis we need a two-tailed test. We also know that we are testing this hypothesis at the 0.05 level, so that means that that 0.05 needs to be split evenly between the two tails, 0.025 and 0.025. I put my legend up here. Degrees of freedom is 28. 15 plus 15 minus 2 is 28. So degrees of freedom is 28. If you need a refresher, I put a little footnote down there, but we've been through that many, many times before, so hopefully you've got that down. Degrees of freedom of 28, an alpha level of 0.05, and we know we need a two-tailed test. So it's this information that allowed me to turn to the t-table to pick the right table to t values, which I placed right here. T equals negative 2.048 on the left side and positive 2.048 on the right side. And again, that standard error, that is the amount of error that I could reasonably expect would occur by chance alone under certain conditions. And what are those conditions? They're right there. Whenever I say the word conditions, I'm referring to what's in the legend. 28 degrees of freedom, an alpha level of 0.05, and a two-tailed test. Set it up. We're all set up. Now, page 2 of this example. Calculating data generated t. Here I simply repeated the t formula, which you've seen before. Mean sample 1 minus mean sample 2 divided by the standard error of the difference. I'm going to turn now to calculating that, but like before, because there's so much math involved that I did one step at a time, you can review this and hopefully see exactly where each number came from. If you have any questions, you can of course let me know, but it should be fairly self-explanatory. I followed the order of operations and simply plugged in the numbers where they needed to be. The standard deviation for sample 1 divided by the square root of sample size 1. The standard deviation for sample 2 divided by the square root of n for sample 2. Squared each value, added it together, took the square root. Long story short, literally, that's a long math story, but literally long story short, I came up with a value of 0.803. That number is the standard error of the difference. That number is the standard error for the two samples together. So now I'm ready to calculate my data generated t-value. T equals mean sub 1 minus mean sub 2, the mean for our Soc majors minus the mean for our fine arts majors divided by the standard error for the two samples together. Now it's just a matter of plugging in the information that I already have. T equals 3, that's the mean for sample 1 minus 8, that's the mean for sample 2 divided by, excuse me, 0.803. That came from our calculation of the standard error right there. Boom. T equals negative 5 divided by 0.803. T equals negative 6.227. Negative 6.227. That is our data generated t value. That is the amount of standard error that separates our two samples. In fact, I wrote all that out there. That's the amount of standard error between our two sample means is 6.227. There are 6.227 units of standard error separating our two means. Here's my question for you. Is that a lot? Is that a little? Is that an important amount? Well, let's find out. That's Dr. Holsinger in the background. Say hello to the chair of the Criminal Justice Department.
Hi, everyone. I hope you're doing well.
Most of them are. So this is the probability distribution. You saw this. You saw this drawing before. It's the t probability distribution. Two tails. 0.025 in each, the table t values, we've been through this before, that's the legend, 28 degrees of freedom, alpha level of 0.05, two tails, that's all expressed in this drawing. All I need to do now is plot where my data generated t value is, and it would be right here. It far, far, far exceeds the amount of standard error. It's way in the tail, way in the rejection region. It far exceeds the amount of standard error that I could expect to occur by chance alone. Therefore, reject. It fell in the rejection region. Remember the tails of the rejection region. Also remember, because this is a two-tailed test, I was open to finding a difference on either side. It happened to be on the left-hand side. So I reject the null hypothesis of equality. I reject the null hypothesis of equality, and here's my conclusion. The two groups differ significantly regarding the extent to which they skip class. The amount of standard error, this is important language, the amount of standard error between the samples can't reasonably be attributed to chance or sampling error alone. And that is all reflected on the handout that I've been showing you on this YouTube clip. And also, of course, it's available on Blackboard as well. So I hope you found those two examples helpful. I hope that those examples will allow you to do the homework for this week. As always, feel free to email with any questions. The next week after this current one, I believe, is exam week. And so most of what I post on Blackboard and or YouTube is going to be hopefully in an effort to help you review for exam number 2, which is coming right up. So keep that in mind. But for the meantime, just shift your thinking from t-test for one sample to t-test for two samples. And good luck this week.